respected editor and dear friends, good evening all. Today's class about transformer maintenance. First we will see three-phase transformers. That will be elaborated. Then conventional transformer, then comparison. Types of transformers. There are three types of transformers in three-phase locomotives. One is 6500, LOT 6500, 7500, 777. The 6500 is for WG 9 locomotives. The rating is 6531 kVA. Only traction, auxiliary, and belt winding only. Then 7500 kVA is 7505 is 7500 kVA, including one bottle. In addition to this, one bottle rating will be there. Then 775 kVA, two bottle ratings. That is the increased rating. Types of locomotives where we are using WG 9 locomotives 6500 and 7500. WP5 or WP7 we can use. But if you are using WP7, only one bottle rating will be there. Then 775 also both WP5 and WP7. Here we have said bottle winding is not available in the 6500 kVA. One winding is 945 kVA, 750 volt output. Two winding available in 775 is 960 volt output. 622.5 to two windings. Weight approximately all are equivalent 10 tons. This is simple diagram and we have one primary winding, then four traction windings, 1, 2, 3, 4, then auxiliary winding one, output is 1000 volt, total load winding 960 volt, and one filter winding 1154. Apart from that, two series resonance chokes available for traction converters and 6 auxiliary converter chokes available for auxiliary converters. This is open view. This is main transformer. That is bar chokes. We have told 6 windings to be there. No, that is 6 bar receiving chokes. Bottom one is SR resonance choke. This is bushing arrangement here. This blue color mentioned is traction winding. Here, there also. And this is series resonance choke. One U is coming from A33 that will be connected to transformer. That is one U. One B is return. Through the return brush it is connected to track. 2 VF is filter. This four bushing is for total load winding. Bottom one is bulb. Let's say top that 6 windings with there. This for receiving chokes. Let's see. The special features of the transformers are: transformer is in three-phase load transformer is mounted in underslander that we all know. And transformer is designed to feeding GTO or IGBT based power and auxiliary converters load. And very high impedance between primary and traction windings to limit the short circuit currents. And 100% decouplings between windings. It means that electrical isolation between the different secondary winding and auxiliary windings. And use of continuous transposed conductor for windings. Transposing we know to equal distribution of current. That arrangements we can see. Like the transposing cable we are doing now, same concept. The winding will be laid in such a manner. To equal distribution of current and equal resistance. Then this construction windings. This one type of winding only for better cooling purpose, like and good axle strength. For this, disc winding is being used. Then transformer and consider tank of aluminum. Tank of aluminum only. Then rapid traction coupling between transformer and converters in IC. In converters we are using 5 tanks that will be fixed with the bolt and nut. But here replacing it's connected with the quick release coupling, that is called switchy coupling, we can say. In references, specification for transformer is old also available, but this is the latest one, 456 and 660. The related MS is 360. Shifting of transformer conservator expansion and conservator tank. Originally it will be in OCB valve. Due to OCB working condition, that expansion and conservator tank fixings are getting cracked and broken. So now it is being shifted to ERSR. But our locos all shifted. Initially some 4-5 locos we have shifted. Other than that, all locos came with modification only. Then related SMI 228 bushing LVT connections. Previously some failures has come, but due to non-standardization of bushing connections, every manufacturer will follow one instruction, one type of connections. Then particular make failures has some due to overheating or melting of the bushing connections and all. Then when SMA has come to standardization. According to that, this is called bushing oil seal tightness nut. This is for connection. So between this nut and this nut, 3 mm gas should be there. Then this is bus bar link. Bottom one plate washer should be there. Above one plate washer, then spring washer. Previously this arrangement was not there in particular manufacturer. So now this has been standardized to all transformers. Then TC 76 for oil leakage of transformer using some covers. This is for simply we can say kit. What are all the items to be changed? What is the material? Oil seal material, gasket like that. So these are the reference for transformers. Then transformer tank. Transformer tank is made up of aluminum for high strength. This says the weight. Provides high short circuit impedance 59%. The stay losses are less. In conventional loco it is the MS mild state, here it is aluminum, so the losses are less. And tank weight is around 1 ton, 966 kg. This is considered tank. Now we will say in conventional loco it's considered tank, but here it is expansion tank. This is also aluminum. One oil level indicator will be there. Then air dealing will be there. This is the silica will be there. Capacity of the tank is 137 liters. 2 tanks will be there. Another next thing is radiator. This also 2 units will be there. 1 unit is called the 2 radiators will be sandwiched here. Top one is for coolant, SR coolant radiator. Bottom one is for transformer oil. Both are sandwiched. These both radiators will be cooled by single OCP only for 1 unit. Another one is so both will be cooled by OCP. The volumes and all available. Specification technical class.
This separate பண்ண முடியுமா அந்த ரேடியேட்டர்?
பண்ணலாம் சார். மாற்றலாம். சேம் வேக்ல மாற்றலாம். Suppose coolant radiators only leaking means we can change. The lifting of transformer. Though it is aluminum tank, we can't lift as we like. That top cover bolts should be tightened. Otherwise, that if you are lifting the transformer without the top cover, buckling will come because of aluminum tank. So first care is the top cover should be tightened. All the bolts should be tightened. So second thing is that rope angle should be minimum 60 degrees. Otherwise, that again also that stress will come. The angle is less than 60 degrees means lot of stress will come on the tank. So minimum 60 degrees should be there. We are using more than that, I think. If we are calculating 60 degrees means the groove length should be, groove length will be around 2.1 meters. We are using 2.25 meters length. And factors affecting life of transformers. Effect of moisture on transformer life. Presence of moisture in oil is highly undesirable. This will reduce the higher strength of oil. So automatically the transformer life will reduce. Second thing is effect of oxygen. This also, oxygen will be present inside the transformer due to air remaining in the oil. So oxygen reacts and decomposes the cellulose of insulation. So this also affects the transformer life. And effect of solid impurities. When manufacture time, lot of small bursts and dust will be there. That should be cleaned. Otherwise that also will cause.
ಇದೆಲ್ಲ ಎಲ್ಲಿ moisture
Sir, we are opening the transformer, attending. Immediately, as per manual they are saying, within 3 hours this should be done. If it is more than that, automatically the moisture will be observed. Since the paper insulation is hygroscopic in nature, the moisture will be observed quickly. But releasing is very slow. Even though when we are circulation, it will be released slowly. So that moisture will affect the draining strength of oil. It will automatically cause the short circuit or anything. Then fourth point is effect of varnishes. Varnishes where we are using the winding, that also will affect. Some synthetic varnishes having acid inhibiting properties, that is okay. Some varnishes having oxidizing effect. Effect of slackness of winding. In new transformer, whatever may be new equipment after working or sometimes some slackness will come. That to be attended. Same like in transformer also winding, that slackness will may cause problem. In transformer oil, the capacity of transformer is 2000 liters. This serves as a cooling and insulation agent. Specification is IEC 60296.
Sir, when the transformer other capacity sir?
Other 2200 around. Conventional
2000.
Condition monitoring of transformer. Condition monitoring we are doing by taking the samples, oil samples. The periodicity of oil sample we are taking mentioned ICO, A first, and every schedule in previous loco and POs, IOs. The following points to be noted when we are taking the sample. We will check some points, some oil grade erosion we will do. Balance all points will be done by lab. First appearance should be pale yellow. The color is changing means it is some due to aging or oxidation. So that will be present. Due to aging also the color will change, or oxidizing also the color will change. So it should be pale yellow. Color changing means that some technical specification they have mentioned. The color is very bad means automatically lab will reject it. So now locus maximum pale yellow. Slight changes also we will not allow. Lab will automatically reject it. Then oil breakdown voltages. Permissible limit is 30 kV, but we are permitting about 60 kV. So 50 kV. Filter drive should be 60 kV. Then third part is acidity in oil. How much the permissible limit? That it is coming within the limit only. And water content. New oil should be at 25 ppm. In service 30 kV. Then another important factor is dissolved gas analysis. When we are taking sample, this acidity, water content, dissolved gas, all the lab will do, and they will give the report to us. In that report, this gases values also they will mention.
Yes.
Based on the life of the transformer, we can identify or we can analysis further. Less than 4 years means some value, 4 to 10 years, more than 10 years. that which gas is present, what is the reason behind that means we can see. Suppose hydrogen is coming, methane, acetylene, why this gas is coming, then what is the reason we can see. Methane means it is low temperature hotspot, ethane is high temperature hotspot, ethylene is strongly overheating, acetylene is Arctic, hydrogen is partial discharge, carbon dioxide thermal decomposition of petrol station. These values we will get from lab. Then on ratio method available. Based on this method, what is the temperature happen inside the transformer? Because we are telling low temperature hotspot, high temperature hotspot, strong overheating. So that values we are calculating in this table. Some readings will come that we can find out what is the temperature happen inside the transformer. The next year we can see. Suppose the T1 means thermal column is less than 300 degrees, T2 is 300 to 700, T3 is above 700. Testing of transformers. Insulation resistance test. We are doing with mega 2.5 kV and 1 kV. Conduit test of all windings, winding resistance, then ratio test. Ratio test means we will give 231 input to the primary, 1Q and 1B. Correspondingly, that output voltage will be measured. Then winding inductance test. Purification of transformer oil. These are the parts will be filtered during the suppression of oil, suspended impurities, water contaminants, gas removal, acidity correction, then dilation of oil. This after filtration, this will be improved. It is then cold circulation for 4 hours. Cold circulation means when we are starting the circulation, initially for 4 hours that heater should not be switched on. If we are switching on the heaters, automatically the oil will be heated up, then the impurities and all will be mixed in the oil. It will not be filtered in the filter. So initial 4 hours we have to circulate without heater, then the impurities and all will be filtered in the filtration plant. After that we have to put heater, switch on the heater, then normal practice will come.
How is the United was like
Methane is that inside some suppose loose connection or something, winding, bracing, anything available. The temperature will be less. So that gas is coming in, so it is called low temperature hotspot. So again that after some time it will be activated now. Then the temperature will be increased. So then high temperature hotspot, ethane will come. But normally one gas will not come, it will come combinedly only. Then ethylene available means normally we are getting 3-phase transformer, ethylene gas is only, it is strong overheating. Other gases will come, but the part is less. Corresponding to what is the reason? Methane means low temperature hotspot, ethane means high temperature. Arcing available means automatically acetic will come. Okay, sir. Example will come. Next case studies will come.
Acidity correction might be how this filters.
Filtration, some alumina oil, see, alumina sir, activated alumina oil, sir. That will do that also.
Is the filter periodicity changing or every new function? How?
Every 6 months and every year.
The number of separations.
Yearly 6 months some filter they are changing, annually some filter they are changing. And purification of transformer oil. This is temperature curve. This is insulation resistance curve. Initially, when we are starting the circulation plant, the temperature will be slowly increase. That time, that insulation resistance will come down because that heating takes place. From that time, that moisture will be drained out. Moisture will come out. So, in such period, that insulation resistance will come down. After certain period, temperature will be constant. That setting value is 70 degrees, then temperature will be constant. For some instance, that insulation resistance also will be in lower level for some time. Then when it will be starting increasing, that time you can see that sufficient level is reached like that. If we are cutting with BDV measurements, it is wrong. When immediately we are starting the plant, then immediately we are taking the sample, then BDV will be available. But based on the BDV value, we can't judge whether all the gases are filtered or it is fully saturated. We can't say. So based on this insulation resistance only we can say. Okay. And cooling concept of three-phase transformers. Simple diagram only we can see. A transformer. One side one pump, oil pump. This is radiator, coolant radiator. Transformer oil radiator. OCD. Then the coolant pump. Yes, sir. Then the expansion tank will be there. This is for coolant tank. This is both the transformer expansion tank. From that, here only I have told that quick coupling. It will be connected to transformer both end. Then this also both end connected. And torque values. Three-phase transformer we are using in all the connections the torque values only. Each bushing may be assigned to traction bushing, SR, choke, bottle loader and other values also. Then transformer top cover, then bushing plate, transformer fixing. Fixing is 675 millimeter, tank plate is 70, bushing plate is 40 millimeter. And conventional rotor transformer. Where we have told it is primary winding, here we will tell auto winding. From the number of tappings as we have taken, that is connected to another transformer primary, then secondary. This is one transformer for 1000 volt output. This is another one. This is for TM1, 2, 3, 4, 5, 6. This is auxiliary winding. Two windings available. The output and the written there. Construction of total 3 limbs will be there. This first limb is auto winding with auxiliary winding, and both corner auxiliary winding will be there. Middle auto winding will be there. This 2 limb is for that secondary transformers. Comparison. Capacitor transformer 3 phase and conventional. In conventional 3900 kV and 5400 kV available. 5400 for WP4 and WP7. 3900 for WP1 and WP4 and WH5 also. Fitting arrangement. 3 phase is underslung. Conventional is fitted in the superstructure. Tank body, non-metallic aluminum. Conventional MS. Here tank sensor will not be there. Conventional is available. Oil pump 2 numbers. Conventional 1 number. Oil specification is 3 phases. IEC 60296. Where it is 335 2018. But more or less the testing methods are same only. There is no much difference. Consider radiator. Here it is 2 numbers. Conventional 1 number. Radiator 4 numbers. There 1. Oil will go as 2. The number of bushing based on the rating of the transformer it will vary. In 2005 kVA, 34 bushing is 70 millimeters. Case studies. These are abnormal cases. Local number 37863. This data from this is 31.5. The sample were checked on 19. First schedule in 3 months gap. So the transformer life is less than 4 years. Here methane value is specified is 50. Here octane is 86. Ethylene is specified is 100. Here it is 210. It is not even worked for 3 months. 3 months only it is worked. So the first after ICO first schedule we have checked the readings. So this then hydrogen is 100. Here coming checked is 137.8. So these 3 gases are more. Then definitely some problem is available in the transformer. So we have opened the transformer. Ethylene we have told strong overheating. So here we can see. Here after open the transformer. Here in the photo it is some clarity is available, black color. But when we are seeing the transformer, this much black is not there. Some because it is bound with some craft papers, something we have filled up here. So after opening, we are checking this one new bushing. One new means either the cable coming and connecting to the transformer lead, primary lead. So that bushing, the craft paper slightly color changes, some slight black. Normally the craft paper color is this color, this normal color. Here it is slight black marks are available. Then remove the paper insulation. After that we can see some carbonaceous, some due to overheated, some carbonaceous happen, strong overheating has happened. If it is continuously working means then arcing will take place. Yes. That connection is slack. In the manufacturing time, they will not take this videos are video available not here, but the connection is not taken. Not only that part, another winding also some color changes are there. Then when you open that, there are also some color changes. This one case. Second case is that what we are told that ratio method. What is the temperature coming inside that? Second case, sir, that they have taken a transformer to practice and another warning. Second cases, there is some P79, same less than 4 years only transformer. Here also ethylene is more. Instead of 100, yes 173. This we have calculated in the ratio method. When we are checking the ratio method, the third T3 fault has come. When the 3 columns are fulfilling means that column we can take that what is the temperature. T above 700 degrees has come. T3. When we are calculating the values, that we can put the value. Then that C2 ratio we can see. C2H2 acetylene by ethylene, methane by hydrogen, like that we have to calculate the values. And we can see the result. So T3, all the bottom third column is fulfilled. So T3 fault has come. Then we have opened the transformer. So bracing joints in the winding, bracing joint has overlaid. There we have seen the bushing, here it is bracing joints. After opening, some full black colors. Then this transformer they have taken and they have and third case is oil leakage cases. Both are different cases. This is called bushing plates. In the bushing plate, over that top cover will come. In between that one gasket is available, this black color o-ring like that. So it will be accommodated in the slot, but here the thing is the gasket length is more. Instead, I think 3930 mm should be, but more than that it was there. When they are fixing, assembling, they have accommodated that o-ring like a zigzag portion. So it has seated. After some time of service, it has started. So that is one case. Second case is that this gasket will be joined in some specified this thing. The joint is not proper. Second cases. So through this is a top cover gasket. Through this leakage has come. So these are 3 cases.
Pushing 6 plate isolated sealed.
இது சார்
machine fixed plane இருக்குல்ல, fix பண்ணி ஒரு bottom plate இருக்குல்ல.
இது வந்து புஷில வந்து ஃபிக்ஸ் பண்ணிருக்கு சார்.
அதுக்கு இது சீலிங் இல்லையா, மாடல் சீலிங் இல்லையா?
புஷி பிளேட் மேல டாப் வரும்.
இல்ல அதுக்கு இதுக்கும் மாடல் சீலிங் கிடையாது. அப்போ ஆயில் வந்து இருக்குமா? இது சொன்னாங்க ஆயில் வழியாக.
இந்த சாசல எனக்கு புரியல.
அதாவது இப்போ புஷிங் டிஸ் பண்ணி அந்த கிரேட் ஆஃப் பண்ணி இருப்பாங்க.
ஆமா சார்.
அதுக்கு பாடிக்கும் சீலிங் இருக்காது.
இதுல வந்து சீலிங் இருக்கு.
அது இல்ல சைடு
இருக்கு.
அப்போ ஆயில் அது வழியா வெளிய
அதுதான் வந்துட்டு இந்த ஓரிங் மேல ஒரு பிளேட் வரும். இது வழியா வராது.
ஆயில் இருக்கு.
ஆயில் இருக்கு.
ஆயில் தான் இருக்கும்.